Hello folks, this is Mr. Dan coming to you from the Landscape Design Classroom, and today I'm going to talk to you about managing pH of greenhouse growing media. So the main idea here is how can I get the best acidity level in growing media? So whenever you're working with different soils in the greenhouse, medium, any of that stuff, additives, any of that good stuff, you want to make sure that you have some acidity within that soil. So we're going to talk a little bit about that today. Just for your info on the right here, we have some different growing media coming together. Looks like we have a little bit of vermiculite in there, along with some perlite, which we talked about in a previous lesson. So if you want a little bit more info on those, please go back and check out one of my other videos. So let's talk about pH levels. Numbers below 7 are acidic. 7 is a neutral base, which you compare to distilled water, which hasn't been touched by anything else. It's been fully purified. It sits at a nice base level. So that's the best thing you can ever compare acidity and alkalinity to is that neutral base. And then numbers above 7 are alkaline. So what is effective? Nutrient availability and plant physiological responses. So if we take a look at some things that are acidic here, we have everything from pH of 0, which is a crazy acidic, which would be a battery acid, soda, which is about 2.5. So if you ever get like that acid reflux, that's soda, that's really working in your system. It's really probably not that great for you. And then going above your distilled water to pH of 7, you get into alkalinity. And that'd be something like seawater with salt in it, baking soda, and something really terrible, especially if you get in your body, would be bleach or liquid drain cleaner. So what do acids do? Acids mixed with water dissociate or ionize into either hydrogen ions, which are electrically charged atoms, or anions, which are negatively charged ions. There's two kinds of measured acidity. That would be active acidity, where there's hydrogen ions, which dissociate, and then your potential acidity, which are those that are capable of dissociating. So evaluating pH levels for soilless greenhouse growing media, you have some, if you have an extremely low pH, that's going to be about a 4.5 or less. Or if you have a very high pH for growing media, that would be a 6.4, 6.8. But what you'll notice here is there's no alkalinity in these soils. So you want to make sure that you're staying on the acidic side. If you start getting alkaline, it's going to be extremely tough for you to grow anything within that greenhouse environment. So acidity is a good thing here, folks. So moving on, ideal, at our second table here, that's an ideal media pH values for some common greenhouse plants. So we have anything from apples to tomatoes, but what we'll mainly be focusing on here is greenhouse plants and ornamentals. So our main focus here should be the hydrangeas, the blue flowered, the pink flowered, but you will notice that you want more acidic soil for those blue flowered hydrangeas compared to those pink flowered ones. If you can really grow a really nice blue flowered hydrangea, you can pretty much grow anything in a greenhouse. So glass electrode pentometer. So these are always going to stay wet. They're most accurate and widely used tool to test pH of greenhouse growing media. We'll be using these here in class. Should be stored wet, as I said, and recalibrated for high and low values to remain accurate. We'll get into those a little bit later, though, because we're going to use our regular soil testing kits to get started here in the greenhouse. So moving on, leachate pour-through method. So as you guys can see down here, you want to have a water flow-through capacity whenever you're testing your pots. A lot of people think that, or a common misconception, I should say, is that you should be able to fill up your pot with water and let it sit and let plants grow. No, that is not the case at all whatsoever. So you want to make sure that your roots, especially in the greenhouse environment, have a lot of room to grow and can get through the soil, or else you're never going to get root growth, and eventually your plants are going to start to yellow and they're going to start to die off. So you want to make sure that you're using soils that are light, fluffy, something for them to grow into easily. And then later on, whenever they get into the ground, that's what they'll be strong enough to burst through some of those harder soils. So you want to test the liquid draining out of pots after watering. As you can see down here, that's that leachate. It does not disturb plants. So like I said, you don't want to disturb the roots. You want to let those roots grow and prosper. maybe variable measurements, and then saturated media method. So this is varied results depending on method used. Sources of variation can be how samples are dried, water content of the medium, and soluble salt concentrations. So steps for determining pH of soilless growing media. So some of the soilless growing that we do in class here would actually be from our hydroponic system. We also have a science class here that does aquaponics using aquatic life. So you guys would get a little bit of everything if you're in class here. So you want to collect a representative sample. You want to air dry that sample, and then you want to mix media and water and allow that to equilibrate for about an hour, which means it's mixing together, and eventually you're going to be able to get your results from that test. So if you have a slightly acidic soil, depending on what you're trying to grow, then you're probably in the right place. So, and then test for pH after stirring for about 2 minutes. So just like we would with our soil testing kits, we want to make sure with those that we get 3 sample areas from 3 different areas of the greenhouse. Make sure those are dried up, put the pH medium in, shake that stuff up for about 2 or 3 minutes, and then see what color that turns into. But we'll get into that a little bit more in class. So nutrient availability. Nutrients and other micronutrients are more soluble at low pH levels. So they're going to start becoming a little bit more solid. So the lower your level goes, the more solid it's going to get, and you're not going to be able to get water flow through capacity. So like I was saying before, you want to make sure you have that light, soft, airy soil. So you can make sure you're always continually testing when you're in that greenhouse environment. Many other essential elements are insoluble at a pH level below 4.5. So look at what you're trying to use. We have a lot of different examples in our greenhouse, but just be aware of things becoming soluble, insoluble, and what's your happy medium here, especially to make something grow. On the right here, we have a pH meter, has a glass pentometer inside. So we have our gauge up here so that we can see what our pH is, and it actually even tells us our temperature down here as well. So there's a lot of different testing methods, and we saw 2 separate ones here in this presentation today. So an optimum pH level for soilless greenhouse growing media is going to be about 5.2 to 5.5. So if you can stay within that range for most things, you're going to do okay. Some stuff you're going to want to have a little bit more into that like 6.0 range. But if you can stay 5.5 to 5.2 to 5.5, then you're going to be just fine. So most plants do best between 5.5 and 7.0. Honestly, I think you can keep it between 5 and 7.0 and you'll be totally fine. So adjusting pH levels, how do we do this? Ground limestone, that's most commonly used to increase your pH. So that means you're going to be increasing to alkalinity. So typically this is more used in the lawn care sector whenever you're using limestone. It is great for greening up that grass in a pinch, especially if you have a customer that kind of doesn't like that their grass is growing in like a light green color. Hydrated lime, calcium hydroxide, dolomitic lime, or calcium magnesium carbonate. This is often the best choice. Also, it supplies magnesium. So this is great for a greenhouse. Like I was saying before, ground limestone is going to be more for your yard, and this calcium magnesium carbonate is going to be more for your greenhouse. So flowers of sulfur, it's slower and it requires a bacteria. We don't really get into that too much here in class, just because the process takes a little bit longer than the time we have granted. But anybody that wants to get into that, I will gladly go over with more. So that's the end of my presentation. If you have any questions, you can contact me down here in the landscape design classroom. But I appreciate your time today, folks. Have a great day.